So we're going to start with connecting English with math. So we're going to look at the transition from taking the natural language type of topics to actually working with mathematical statements. We can often model a lot of real-life mathematical situations using the common mathematics statements and mathematical problems that we work with in class. So this way here we're going to look at how we can take those statements and situations in real life and start moving towards making those into mathematical models that we can actually then make calculations on. We're going to start simple, and then hopefully as we progress through the course we'll see this happen more and more. We'll get to some complex situations that we can then translate into mathematical models and use those to calculate and determine the outcomes or possible outcomes of various situations. So we're talking about natural language here, and I mean math language is kind of comes from all over, so there's lots of situations, lots of different cultures, lots of time, be it thousands upon thousands upon thousands of years of development from across the globe. So that leaves us with a huge range of words, and especially because we're doing math in English, and English is probably one of the worst languages in the world for the number of origins of it. So now we have to figure out how do we transfer the various words that we use into mathematical symbology. So up on the screen here you're going to see the different types of words that are used for some of the common algebraic situations, such as addition. So when we're working with addition, some common terms that you would see include add, addition, but other ones you might see increase is very common, or how many. So when we're looking at the ideas of counting or growing, you can often think of addition as being something that should be growing in a linear fashion, which connects with what we're going to be talking about. Total, together, words like that. Subtraction, you're looking at a difference of things, how many are left or leftovers, minus, reducing things, taking away, and so a general idea of going downwards. Although in both additions and subtraction case, note that it's not always going to go down. Multiplication in general, the idea of multiplication in general tends to be an increase by collecting groups. So you're making equal groups of items. If I have 20 equal groups of 5, something like that. Something by 3 by 4 would be a multiplication type of question. Lots of, and when we say lots of, we don't mean lots in the phrase amount. We mean lots as in groups. When we look at division, we're looking at the quotient of the as a result, but we're breaking things into maybe equal parts, so equal groupings. This is about fractions. Division is all about fractions. We're maybe making ratios or splitting things, so there's a large number of words. And these are not an exclusive list. These are just some of the common terms you'll see. Now as we flip back to the situation we have on the board here, we have this question to translate the following math statements. So starting with statement A, we have 91 more than twice the cube of a number. And so we just want to translate that into a mathematical statement. So we want to use mathematical notation to do such. So in this case, we have the number 91 more than relates to addition. Twice references times 2, and the cube of a number, well, cube means to the power of 3. So the cube of a number, and a number is our unknown value. We don't know what it is. So let's use the letter n to represent that unknown number. So we're going to have the cube of a number, that's n to the power of 3. So 91 more than twice the cube of a number. Well, let's take a look at this part now. Twice the cube of a number is 2n cubed. Twice the cube of a number, 2 times n cubed. And 91 more than that would be plus 91. So there we have 91 more than twice the cube of a number. So this next question here, we have 5 times a number, comma, and this is important, comma, decreased by 2 is 18. 5 times a number is isolated by that comma. And so 5 times a number would be 5, and again we'll use n for our number. So 5 times a number decreased by 2, well that means minus 2, is, and is in math translates to the word equals, so equals 18. So here, this one comes out nicely in order. 5n minus 2 equals 18. Now this here, it becomes important to note the slightest difference from the last question of this. Other than the significant one where we have a result of 10 versus 18, but right here I mentioned the comma. The comma is missing, and the comma is missing, and it changes how this statement works. 5 times a number decreased by 2. There's no little pause here. That comma adds that pause in the language. There's no pause anymore. So 5 times a number decreased by 2 is now connected. So this here, a number decreased by 2 becomes n minus 2. We're multiplying that by 5. So there's 5 times that, which is now 10. Thus giving us a completely different result. So the language and how we express things, adding that little pause with the comma, can make a difference in what we get. Because now we have 5 times n minus 2. We're using the brackets so that this happens first. So n minus 2 happens before we multiply by 5. And then we'll end up with a result of 10. So this is very similar to the previous question, but we get a completely different result in what it would equal. In both cases, I based the idea off n being 4. So n in both cases was 4, but because we don't have a comma, the final result's different because the way the statement is made changes the equation. So in this last case here that we're going to look at, we are taking a look at the surface area of a cylinder side. And so just as a quick descriptor, the surface area being that it's a volume type of shape, is a three-dimensional shape, so we're finding the area of one of the surfaces. We're not worried about the end caps, the top and bottom circles. We're worried about that rectangle that makes up the side of the cylinder here. So the surface area of this side portion only. So in this case, the surface area of a cylinder side can be found by multiplying twice the number pi by the radius and the height. So we're multiplying times twice, that relates to a times 2 somewhere, the number pi, so we often use that Greek symbol pi or 3.14 as an abbreviation, by the radius and the height. So the radius, we can use an r for a variable and h here for the variable for the height. So we need to multiply this 2 and pi, twice pi, so there's twice pi, times, by multiplying the radius and the height. So multiply this by the radius, so times the radius and times the height. Well, again, we don't need those multiplication symbols because it is confusing to put the x in there. We could put the dot product, or sorry, the dot notation, or we could put 2 pi r h, but again, this looks a lot more confusing down here than this top portion here, especially if we do not include those dots. So this method here is preferable.